This session will review the Earth's climate from a period of time of 550 million years ago until 65 million years ago. We are looking at the fifth panel in the climate project the temperature graph, and that's this graph here is composed of three different colors. There's a red line, you can see it here. That's actually considered the average temperature for the period. There's a black dotted line, you can see it here. That's data from the same time but derived a different way. That's why there are some deviations between the black and the red. There's also this wide yellow bar here following the temperature graph that indicates areas where there's wide uncertainty in the specific value of the temperature at that point in time. We'll start out 550 million years in the past. Note that the temperature of the Earth is estimated to be very high. And that's in essence over 20 degrees Fahrenheit higher than today's current average, which is the average between 1960 and 1990. So the Earth here is running really hot. You can also note that carbon dioxide values are extremely high at this point in time we're looking at values around 6,500 parts per million. That's about 16 times the present value. Finally, let's look at the sea level curve. That's this red line here. This zero value which goes across this way indicates today's sea level value. So you'll note that almost the entire period of time during this time span sea level was much higher than it is today. As we start out going forward in time, sea levels indicated to be just over 100 meters higher than the present value. Also note the plate tectonic display. You won't recognize this world because we're looking at one of the old supercontinents. It's called Gondwana. Note that most of the land is in the southern hemisphere near the South Pole. That's one of the reasons why sea level is low here and will go up higher here as we travel in time. You're going to see a lot of plate tectonic action up here as we go forward in time as indicated by the green X. You can see that there's a lot of changes in temperature, sea level, carbon dioxide values, as well as positions of the continents. All these things come together at the same time to define the climate in the Earth at that point in time. We continue going along. We're going to run into a period where there's another ice age that's here, and this ice age is occurring when temperatures are estimated to be over 10 degrees Fahrenheit higher than they are today and the sea level is almost 400 meters higher than today. I'll point out that carbon dioxide has dropped substantially at this point in time. Here it's running close to 10 times what it is today. Regardless, there still was an ice age with glaciers coming and going mostly in the southern hemisphere. And that's because there was a lot of land down here that afforded the opportunity for snow to fall and ice to build up and snow to build up and glaciers to build up. And that's why there was an ice age during this period of time. It was short, I think was only about 30 million years. Then things changed, temperatures went up, sea level continuing to drop. And that drop has nothing to do with the glaciers. It was mostly to do with the change in the plate tectonic arrangement of the land mass on the Earth. And as we keep going, carbon dioxide is continuing to drop, temperature is really going down tremendously, sea level gradually going down but nothing close to what would be represented by the temperature curve. And as we get down here near this low point we're going to go through what's known as another ice age. This was a long one, about 100 million years. If we go back we can see that there was one point here where one set of data indicated the temperature got really warm compared to where it was during a couple of spikes. But nonetheless, there was still an ice age. And that's because the continents here had arranged themselves into another supercontinent called Pangaea. Now as we continue going forward we'll eventually get out of this ice age, which will be the last ice age for many years, and temperatures spike again here. And now we're looking at what Pangaea looked like around 240 million years ago. Note that carbon dioxide levels are about 5 times higher than today. Sea level has finally fallen, that is to say it's close to what it is today down here, basically at the zero number. So that's an interesting point because we're not going to reach this low level again for a period of time from this point, which is a span of 240 million years until the present. That's going to be a long time before sea level will go back down to this level, which is our present level, and will continue going forward in time. Note the breakup of the continents. And again, the difference between sea level going up when temperatures going up or sea level going down when temperatures going down in this particular case has nothing to do with glaciers because there's no worldwide ice age going on at this point in time. Temperatures are running really high, 15 degrees above the present, and sea level at this point is close to 250 meters above today's level. We'll keep going forward until we get to the beginning of this panel.